Hey guys, just re-recording this video because someone told me I recorded them and uploaded them with no sound, so redoing. So all the graphs we've done in this topic so far have just looked at one variable and worked out how frequent they are. So the example that we did in class, we found how many siblings each person had, and then we counted how often that happened in the class. But the remainder of this topic, we're looking at the relationship between two variables, and this kind of statistics is called bivariate statistics. Bi meaning two, variate meaning variable. So statistics involving two variables. Now when you got two variables, there's always an independent, otherwise known as the explanatory variable, which causes change in the other variable, and this always has to appear on the x-axis. The dependent variable, otherwise known as the response variable, changes because of the independent variable, and this is always on the y-axis. So if you came up with an example that everyone could understand, strength versus weight lifted, what are you changing on purpose that's going to cause the change in the other variable? The stronger that I get, the more weight I can lift. So the independent variable in this case, the independent variable in this situation, the explanatory one, is going to be strength, because your strength explains the change in the amount that you lift, and so the dependent variable in this situation is going to be the weight lifted. For the YouTube video, you'll have time to pause it here and get this section down. But for the video, I'll continue. So the first kind of graph that we're going to deal with bivariate statistics is line graphs. This is used to show variations between two quantities. Really the key to understand with line graphs is it's always going to be passage of time. So the x variable, the x-axis variable, is always going to be time. And it's a line graph because the data points are going to be connected with lines, and that makes sense because we don't change the passage of time. So the connections between the data points are going to be meaningful. Now in a line graph, if the line points up to the right, then it has a positive gradient. If the line points down to the right, then it has a negative gradient. And so for the YouTube, pause there, get those two definitions down. But for my video, I'll continue. So here's the example here. The temperature in a yard was recorded every 2 hours from 6 a.m. to 6 p.m. The line graph below displays the results. What was the temperature at 8 a.m.? So we're talking about the time. So we'll look along the bottom. 8 a.m.'s here. What was the temperature? Look up 26 degrees. What time is the temperature the highest? It's asking what the temperature is. So we'll look on the y-axis. What's the highest it goes? Across there. So 28, 29, 30, 31 degrees. And that was at 2 p.m. When was the temperature increasing? This is a little trickier because increasing means the line is going up to the right. So I was doing that over a period of time. There were different rates of increase, but it was always increasing from 6 a.m. to 2 p.m. Estimate the temperature at 5 p.m. Why are we only estimating? Because we don't have a bit of data at 5. There's no red dot there, but we have the straight line between 4 and 6, and it suggests the temperature is going to be 27 degrees. All right, so that is bivariate statistics and line graphs. Hopefully that helps you out, and I'll see you in the next video.